All right, so right now we should be recording. So I just started a new project and I'm gonna get rid of some of that stuff. We did say that we don't wanna have that stuff for now. And let's make this void and let's make this return. And so I'm gonna do a very quick review of what we did last time. So we talked about pointers and we said if I have a variable that has a value, I can create a pointer that points to that variable. Now, of course, the variable doesn't have to have a value, but let's just give it a value here. And let me create a pointer that points to num. Now, a pointer that points to num means that we're going to have a pointer that has the value, which is the address of num. And the reason why we say points, because it has the address and essentially you can use it to kind of get to num. And we're going to see some of that today. So one thing that I'm going to be doing differently today is I may stop the recording once I'm done with a topic, and then I'll start the recording again when we start with a new topic. So that way we can have multiple kind of segments, and I won't have to chop the video into multiple segments. It'll be already chopped for me. So I'm going to create a pointer that points to num, and because num is an integer, the pointer that I have to create is a pointer that points to an int. So I'm going to say int star and say p1 equals to the address of num. So if we were to go back to the grid of RAM that we created yesterday, I'm going to just quickly do 16 here. And here I'm going to do 8. And I'm going to make sure that those cells have borders. Let's make it like that. Let's say 0.5. Okay. So when I create a variable num, because I know my integer is 4 bytes, I know that this will allocate 4 bytes. So those 4 bytes could be pretty much anywhere for now. Let me put them here. Let me merge this. I can give it another color. Let me give it red. And let me actually shrink this a little bit. And let me give this the value 100. So I can say 100. Let me make sure that the font is small. Maybe what I should do is let me get rid of some of the columns here. Some of the rows, excuse me. Okay, so that looks good. Now, do you remember what the size of the pointer is? I did mention this not yesterday, on Friday. What is the size of a pointer? How many bytes?
8.
8, exactly. So the sizes of pointers on my computer, and most likely on your computer too, is going to be 8. So P1 is going to probably be, say here. Let me merge. Of course, again, it could be anywhere, pretty much anywhere. Those bytes, of course, they have to be consecutive. We don't want to forget that. And the value of P1 is going to be the address of num. So what is the address of num? Assuming that this is my RAM, and we start counting from here, and this is address 0, what would be the address of num? Katie said 9. Not quite right. Anthony said 8, and it's 8. So it's 8 because we start at 0, 0, 1, 2, 3, 4, 5, 6, 7, and this one would be 8. And the address of the integer is the address of the first byte. We don't want to forget that. So essentially what that means is P1 is going to contain 8 because P1 contains the address of num. So this is just kind of a review of what we did. It's kind of important because it's easy to forget kind of the details of this. Now, again, we also say that P1 points to num, and it's because it contains the address of num. So you can think of it as, it's pointing to num. I hope that this makes sense, but if it doesn't, it's okay. I mean, it doesn't really have to make perfect sense. But essentially, when we have a variable that contains the address of another variable, the way we view it is that it points to that variable because we have the address, of that variable. To me, it makes sense. I think it probably makes sense to all of you. But even if it doesn't, it's okay. As long as you know that when we have a variable, a pointer that contains the address of another variable, the way we think of it is that this pointer points to that variable. Now, I did tell you that the size of P1, because it's a pointer, is 8. And right now I'm going to show you that. So I'm going to say printf the size of P1 is %, unsigned long. If you remember that, we did that last week, \n, comma, the size of P1. Let me remove this and remove that. So this one is going to print the size of P1 in bytes. And because P1 is a pointer that points to something, in this case, it points to an int, it's going to be 8. And I'm going to just hit play and show you that this is the case. You can see here that it says the size of P1 is 8. And what I probably should do is say bytes. So in my case, for my computer, and again, most likely for your computers as well, the size of a pointer is going to be 8 bytes. So this is great. This was a good review. Do you guys have any questions about anything that we covered before we talk about a new topic? All right, doesn't seem that you have questions. So let's talk about another topic, and this is important. And this topic is going to probably be the title of the video when I post it, and it's dereferencing pointers. So there is this operator or operation, it's called dereferencing. And dereferencing means if you have a pointer that points to a variable, and that's really what pointers do, they point to variables. They point to, of course, they point to blocks in memory, but in almost all cases, they point to variables. You can take this pointer, you can use the value of this pointer, which is really the address, of the thing that we're pointing at, and you can use it to get the value that we're pointing at. So let me show you an example. This will make a lot more sense if we do an example. I'm going to actually comment this one. So of course, I can say print if the value of P1 is %p \n, comma P1. So we know that. If I play, it's going to print the address of num, which is really the value of P1. So this is the value of P1, and I'm going to say, which is the address of num. Now, of course, I can also print the value of num. We've done that before. The value of num is %d \n num. So this is kind of easy. We did that before. Now, what I'm saying here is using dereferencing, you can print the value of num using P1 because P1 contains the address of num, and you can dereference P1 and that'll give you the address, that'll give you the value of num. So the value of the thing that this pointer is pointing at. Let me hit play, just show you that num is going to be printed. That's num 100. Again, the value of P1, which is the address of num, is going to be that. And let me show you how I can print the value of num using P1. The value of num by dereferencing P1 is %d. Now you should kind of expect it to be %d because num is an integer, so we need to use %d. And here what I'm going to do is I'm going to say star P1. Now here we're using star before the pointer, and if you use a star before the pointer, that's going to translate to get me the thing that this pointer is pointing at. Essentially, get me the value of the thing that lives at this address that is stored in P1. And this one's going to print num, which is, of course, 100. You can see here it printed 100. So let me kind of repeat what I said because this is very important. Here I printed the value of num using P1, which is a pointer that points to num. So I didn't use num here, but I was able to print num, or the value of num. And this is because there's this operation that is called dereferencing, and you can, get or use that operation using this operator, this star. So a few things to keep in mind, and these are very important things that you really don't want to forget. The star that you see here is used to declare or create a pointer that points to an int. The star that is used here is used to dereference. Even though this star is used in the context of pointers, both of them, even though this star and this star are used in the context of pointers, they mean entirely different things. So this star means that we need to declare a variable that is a pointer that points to an integer. That's what it means when we have this. Now here, this star means that we need to dereference the pointer. And dereferencing means, that is, get the value of the variable that we're pointing at. Let me pause here and see if you have any questions. Do you have any questions about any of this? You can give me a thumbs up, if you don't have any questions. Okay. All right, so this is dereferencing, and this is going to be something that we're going to be using when we talk about arrays. It's going to be something that we're going to be using when we talk about passing a value by reference, when we call functions. So right now, what you need to know is all of that we covered, but besides that, I think that's it'll be later. We'll cover the rest later. Now, of course, let me just do a few simple examples. I can say the size of, the thing that P1 is pointing at is %, unsigned long \n, and I can dereference P1. I mean, maybe this is kind of a silly example, but here what I'm doing is I'm getting the size of the thing that P1 is pointing at. And of course, P1 is pointing at num because it contains the value of the address of num. So the size of num is going to be, of course, 4 because 4 is an int. So let me just hit play. Maybe this example was rather obvious, but here you can see it says the size of the thing that P1 is pointing at, which is really num, is 4. So let me create another example, and maybe I can ask you a question. And once I make sure that you understand the topic, we can go to the next one. And I think that you'll be able to answer my question. It's not going to be difficult. I'm going to say char my letter equals to, a. And then I'm going to say char star pointer to my letter is equal to the address of my letter. And then I can print a few things. Of course, I can print if the value of my letter using my letter is %C\n my letter. And the reason why I'm saying using my letter is because, as you may have guessed, I'm going to say the value of my letter using the pointer also, and I'm going to dereference the pointer. So I'm going to say print if the value of my letter using kind of pointer to my letter is %C \n, and I'm going to dereference pointer to my letter. And these two lines should print A, both of them. So you can see it printed A here, and it printed A here. So if we were to go to my grid, how many bytes is a character? I know I asked you this before, but that's okay. Let me make sure that you still remember. 1, okay, that's good. So let's put my character here. And let me say that would be, of course, A. And if you remember, I did say on Friday that what we store is not the letter A, but the ASCII code of the letter A, because everything is going to be a number, really. So I'm going to say ASCII of A is going to be A lowercase is going to be 97. So I'm going to put 97 here. Okay, so another question that I have for you. What is the size of the pointer that points to a character? I think I did ask you on Friday. Not sure if you still remember, but I do want to kind of create the pointer here. So I need the size of it. Anthony said 8. That's exactly right. So it's going to be also 8. Any pointer, again, on my computer is going to be 8 bytes. And most likely on your computers also. If your computer is old, it might be 4 bytes for the pointer. But most likely, it's actually difficult to find 4-byte pointers at this time. So let me do kind of blue here. And what is the value of this pointer? Can you tell me? Think about it. Exactly. So the value of this pointer is going to be the address of this. That's right. And what would that be? Okay, that's correct. That is 414, because we have, again, if we start counting from 0, you end up with 8 here, 9, 10, 11, 12, 13, 14. So that's correct. So what we did here is really represented here. So that's perfect. So one question that some students may ask is, why do we need to define the pointer as something that points to a data type? I mean, if you like, the question is, if a pointer is always going to be 8 bytes, whether it points to a character or whether it points to an integer or whether it points to another pointer, that's actually possible, having a pointer that points to a pointer. We're not going to do that right now. Most likely we won't do it in this course. But really the question is, if we have a pointer and all those pointers, regardless of what they point at, they're going to be the same length. In my case, it's going to be 8 bytes. Why do we have to define the pointer to be pointing at a character? I mean, what's the point? Why is it useful to have a pointer that points to a character and a pointer that points to an integer and a pointer that points to a short? Do you know the answer to this question? It's not the easiest question. And one thing that I should say is, usually when I ask you questions, it's not something that I haven't covered, or it's not something that you cannot deduce. So it's something maybe that I maybe hinted at, or maybe mentioned, or maybe some other information that I provided should give you a suggestion. Let's see, wouldn't be to keep track of the location of an element. Keep track of the location of the element. Not clear. So what if I have a pointer like this? Let me say there's something called pointer. I'm going to create, say, a new data type called pointer, and I'm going to give it the address of that. And you're saying to keep track of the location. That's not clear to me. What does it mean when you say keep track of location? Of course, when we have the address, that's going to keep track of the location. So when you put the address of a variable inside a pointer, that's going to kind of keep track of the location. Let me see. Sorry. The question. So let me repeat the question. The question is, this pointer points to a character, and the length of this pointer is 8 bytes. This pointer is pointing to an integer, and the length, I should say size instead of length, the size of this pointer is 8 bytes. So they seem kind of almost identical. I mean, this is a pointer that points to an int. This is a pointer that points to a character, but they seem to be kind of the same. At least they're the same size. So why did I need to define that it points to a character? What could be a good reason for me having to say that this is a pointer that points to a character? There is char here, and here there's an int. So I needed to define the pointer as a pointer that points to a character, or as a pointer that points to an int. And why would that be kind of necessary? And again, the answer is going to be about something that we covered today. Maybe to identify the different types of values in pointers point to, okay, maybe to identify the different types of values, but why? So Katie's saying it might be helpful to know that this pointer is pointing at an int and this pointer is pointing at a character. It might be helpful. Why might it be helpful?
I just meant because it might not be easy to distinguish since all pointers are the same size.
Okay. All right. Not quite there. So Anthony's saying not all data types use the same number of bytes because you need different operations for different data types. You're all close. You're all close, but I'm not hearing what I want to hear. And let me tell you what I want to hear. What I wanted to hear is that when you dereference the pointer, when you say, get me the thing that this pointer is pointing at, I need to know how big that thing is. So remember, if you look at this code that we have here, I'm dereferencing this pointer. And dereferencing the pointer mean get me the thing that this pointer is pointing at. And for me to get that thing, I need to know the size of the thing. Because if this thing is pointing at an integer, then I'm going to get 4 bytes. And if another pointer is pointing at a character, I'm going to get 1 byte. And if a third pointer is pointing to a short, I'm going to get 2 bytes. So I need to tell C, the language, that when it sees this code, it should get, in this case, 1 character. And the way I do that is by telling it that this pointer is pointing at a character. Does that make sense? So if you actually don't want to dereference the pointer, you don't need to know that this pointer is a pointer that points to a character, or this pointer is a pointer that points to an integer. You don't need that. But because we are dereferencing the pointer, we need to know what the pointer is pointing at. Okay, let's see. So the question is, does it allocate space for the data type of the variable you're declaring? Not quite. It doesn't declare space. The space is already declared. So when we create an int, the space is declared. When we create a character, the space is declared. When we create a pointer, the space gets declared. But when we dereference a pointer, that means go to the RAM, go to that address 14, and bring the value at that address. Bring me kind of the value at that address. And when you want to get the value, you have to know how many bytes you're looking at. If you're looking at 1 byte, that's going to be 97. If you look at 2 bytes, and let's say there are some values here, that's not going to be 97. So it's not about declaring as much as it is about getting the values of the number of bytes. So the number of bytes is important. How many bytes do I need to look at to get the value of that? So that's why. And I'll let you think. I mean, if you have questions, of course, feel free to ask me, and you can think about it and maybe, come back to me with more questions. But it's important to tell you that because you can potentially define a pointer that points to anything. So that's allowed. So you can say, for example, short, say small number equals to, 5. You can do something called void star pointer to small number. And you can say that's the address of small number. You can do that. However, you're not allowed to dereference this one. Because as soon as you try to dereference it, C, the language C, is going to say, wait a second, you want me to get the thing that this pointer is pointing at? What is the data type of that thing? I don't know. Here, when you created the pointer, you told me that it's going to be a pointer that points to something. I mean, void, of course, means nothing. But in this context, it's actually something. It could be anything. In this case, you cannot dereference that because C is going to say, well, I need to know what is this pointer is pointing at. So we're not going to really work with void, but I do want you, or rather I did want you to know that there's a good reason for us to define the data type of the thing that the pointer is pointing at. And the main reason is because when you dereference it, we need to know how many bytes we're going to look at. So this, for example, I'm going to say we cannot dereference pointer to small number because C won't know how many bytes to kind of retrieve. Excuse me, does that make sense? Do you have any questions about this? Okay. All right, so as we do more kind of pointers and arrays are highly associated with pointers. So as we do more of that, hopefully this whole concept will become more familiar. Again, feel free to kind of think about it. Tomorrow we're going to have a session. We're going to keep having sessions until the semester ends. So you can come to me tomorrow and say, well, I have a question. If what you said is true, how does that work? Or maybe you can say, I didn't really understand what you did. Can you repeat some of it? Of course, feel free to try to kind of look up stuff and um, look at resources as well. So this is C, and C programming is you'll find resources on that, you know, everywhere. So it's not a specific topic. Um, okay. So I think this is a good place to stop the recording and start a new one. And when we do that, I'm gonna talk about arrays. So I'm gonna probably create a new project and talk about arrays, and then show you how arrays and pointers are related. Let me stop the recording.